All right, everyone, it is now 2:30, so we can get started. Welcome back to Comp 290. This is lecture 5. We're going to be continuing on from what we were talking about last week with Git and expand your Git toolbox. So hopefully you'll be able to learn a little bit more about Git and hopefully recognize some of the things that you've seen in some of the previous classes. The first thing are some announcements. So because this is lecture 5, we have 15 lectures for Comp 290. So we are nearly 1/3 done, which is kind of exciting. I don't know if you think it's been really fast or really slow, but that's kind of our pacing so far. There will be 2 assignments, both of them. One of them will be very short, and they are not going to be due because there is a wellness day on Monday. We're going to adjust the due dates accordingly. So these will come out in a Canvas announcement. I expect one of them to be released later this afternoon, and then the other may get released tomorrow. There are a few announcements for different events that are happening on campus. The first one is, I don't know if you all have gotten an email, but there are a lot of events hosted by Google at UNC this week. So the department, I think, sent this out in an email. If you didn't get it, though, the information is here. And when we upload the slides to the website, you'll also be able to access this. So these are different career events. For example, you can see there's, in fact, tonight at 6 p.m., there is an interview workshop located in SN 14. There's also some other things here. I think a lot of these are on waitlist, but this one, at least, there is a lot of space. So if you're interested in potentially learning more about software engineering roles and careers, including at an established company like Google, we highly recommend checking this out. There is no limit for experience. So even if you are only in 210 or even in 110, this still would be interesting, and you may learn quite a bit by attending. So the link will be provided in the slides that'll be posted after class. I promise that this time the slides will be posted very timely and will be out immediately. And also, you can check your email from KMP, and he probably sent this out. Another thing is that the Carolina Data Challenge is coming up at the end of the month. So if you are interested in learning more about data science, this is a weekend event. So you can, I think there might even be still space open if you'd like to sign up. So that you can do so. I think the slide for this was in the previous week. And if you go to the CS department's website, it should be right at the bottom with the text, Carolina Data Challenge for the events. So we're going to get started here with a little bit of review from what we talked about last week. So we talked about Git, the purpose of it, and how it is a version control system. We also talked about how we can create Git repositories inside of a directory. This allows us to track the changes of our project using, remember, the git init command that we discussed. And we talked about that our repository, this timeline that represents how our project changes over time, is kind of broken up and denoted by these commits. Right? So we have commits every so often, and commits help us to keep track of the changes that have occurred in a project between like one commit and the previous one, or whenever the project started. So for example, here you may see that there's this commit right here. It has an ID, of course. It's a very long ID, but just for the sake of ease, we've shortened it to 4 digits, or 3D51, and you can see that this particular commit follows this one right here, which is one FAC, and 2 changes have occurred since then in our project, right? So we added here a script.py file. There's a key on this side, which is really small, but in some of the later slides, I made it bigger so it's easier to see. And then we modified a main.py file. And so all of the changes that have occurred from here to here are saved in this commit. We also talked about how commits are very similar to kind of that idea of checkpoints. We used Mario as an example where it's easy to, if something goes wrong in your project, you can go back to a commit and kind of treat it as a checkpoint and start from scratch. So that allows us to prevent any if we're coding and we break something, instead of trying to undo a bunch of things and figure out what we actually did, we can just revert back to a previous commit. Okay, so all of that is review here. This piece is also the slide again from last week, where we talked about what actually makes up one of these commits. So you saw previously that we talked about changes, right? We said that from the previous commit, we made these 2 changes. That's obviously kind of the main piece of a commit. But in addition, we also include a message, right, a commit message, that helps us to specify in a more human-readable way what changes have occurred since the last commit. And also there's some information about the author and the timestamp. So again, this is really, really useful if you're working in large projects where you're working with other people. Because and I think we used this example last time too, if you are working with somebody in a different time zone and maybe you're going to sleep and they're waking up, and they don't have a chance to message you to see what you did because you were asleep, you can look at the commit message, and this will tell you, what they actually did, if they wrote it correctly. There's also an author, which helps to specify who made those changes. So this slide is a rehash from last lecture. Does anyone have any questions on any of these basic concepts with Git commits? All right. So I encourage you, hopefully this is large enough. If it's not for anyone in the back, feel free to let me know and I'll try and make it bigger. I encourage, just like how we have done in the past, where you can work kind of in your groups. I think in the case where there's only one person in a group, feel free to you 3 can go together, you 4 can go together. And just try and work through this. You can either do this on your computer or you can just think about it. The main thing is we want to try and see if we can create a diagram similar to the one that we did here, which represents all of these commands when we run it. So you can talk with each other. If you have like an iPad or paper, you can try drawing it out. Otherwise, feel free to just talk through it. We'll spend around 5 minutes on this, and then I will try and draw this on the board. All right. So you can try and talk with each other. All right. So when we are currently we're in some unknown directory here. You can see that I didn't really print out PWD, so you don't really see what the working directory is. But we do make a folder and CD into it. So you can assume for the purposes of this that our current working directory is going to be something like there's going to be some file extension before this, and then we're just going to have this folder warm up. So we'll have this folder warm up in here, or this directory, and that is kind of our current working directory from the step right over here. So you have this CD warm up, which is right here. We create a new folder and we CD into it. And now we really get started with our steps in Git. Right? So the first thing is that we create a Git repository. So we have this Git init. Now, if you're in another class like Comp 423 or something even higher, we are a little bit more specific in how we actually diagram this. But for the purposes of this, we can do this a little bit more in a free-form way. I'm just going to draw a box here. If you don't need to, this is just representing that this is my repository, and then inside of that is where I'm going to do the traditional diagram that you've seen in some of the previous slides. I'm just doing this as kind of a step where, so you can see step by step what is happening, and the iPad froze, which is, all right, there we go. So Git init, Git init will create our Git repository, which you all probably talked about. And then the first thing is that we have this echo sup, right? And we move this, we use this, the greater than operator, the pipe to, actually, it's not the pipe. Do you know what the technical term is for it?
I just call it output redirection.
All right, output redirection. We're going to use this to redirect this sup word into my hi.txt file. So if you remember from the last lecture, we used this quite a bit, this convention where we have echo and then we have some text, and then we redirect it. Instead of printing directly out, right, to our terminal output, we take it and we simply move it into a file. So that is what this symbol does again. This symbol takes the output of a command. In this case, we have echo sup, which if you remember, just reprints out that text to the terminal. And we take that output and we redirect it basically into a file. So in my terminal, if I were to, and I'll draw another box here, which will actually represent what my folder looks like. So sorry, that is not that good. Let me see if I can, there we go. So we have another box, and this will kind of be my warm-up folder. That way it's easy to see what my files are actually looking like. I don't know what is happening here. There we go. Okay. You can kind of imagine that that's a very badly drawn folder with the little folder tab. And the first thing that we did, remember here, is we wrote this text sup to hi.txt. So I could draw, just for the example, I'll draw a new file here called hi.txt, and I have the text sup, right? So that has been added here. And that is this line. So that is this line. Is there any questions here with the output redirection, how we created that file? All right, great. And so now we have this git add, right? So if you remember in the previous lecture, we used this add keyword to create we were adding changes to like a draft commit. The official term for this is the staging area or stage. So if you see that written anywhere, we kind of have this another box. I think I'll draw that to the side here. Again, these boxes and in the kind of the layout, you don't have to worry about the specifics of this, but it's good to kind of have a mental model of kind of how things are working. So we may have a stage. So this is stage. It's not letting me. Okay. Stage. And this is again kind of our draft commit. So draft commit. That is how we can kind of think about this right now. And we said git add hi.txt. So does anyone have an idea of what this should do, given this layout? With the hint maybe that, remember that the add command will take changes that we make to a file and add it to our draft commit. So what might we want to include here? Yeah?
Hi.txt.
Exactly. Yep. We would add the change that we made. So we added this file, and I'll kind of denote this with a plus. So we added hi.txt, right? So this is a change that we made to our repository. We created a new file, and now we're adding it to our commit, meaning that the change that we made, we want it to be part of the commit when we make it. Any questions with this? This is the main piece about Git, which always confuses students, including even in the higher level classes, kind of the separation between the staging area and the actual repository. In the sense that when you do git add, it doesn't automatically make a commit, right? We're only working with the draft commit, like a draft here. Again, the technical term is stage, but it's easier to just think of this as the draft commit. So we haven't actually saved our work yet. We're creating a draft, but we haven't actually created any. We haven't really created any commits yet. Okay. So how does that sound? Like thumbs up, middle, down. Okay. Good. Perfect. So that is the only thing that we added, and then we ran git commit. So there's git commit, and that is where we actually create a commit in our repository. So when I create a commit, so I'll have a commit right here. So this is a commit. And you can imagine kind of like in the diagram, I have this, sorry, my iPad is frozen again. This is what happens when you update to the new versions. All right, so we can imagine this was our git init, and just like before, right, we kind of had a line to our commit. And I guess, you know what, for the sake of this, I'm actually going to use the same representation as what I did. So I kind of have this flag. I think that'll help to make things a bit more consistent. And remember that every commit is associated with some ID, right? Just like if I go back to the slide over here, if I can get to it. Sorry, everything is breaking right now. All right, there we go. We're there. So remember how we have an ID associated with every commit. This is auto-generated by Git. So Git is going to create this automatically. So I'll add here in my diagram some random ID. So like 1C2. I know that's really, but the ID doesn't matter, so it doesn't have to be readable. And then the changes that have occurred since the previous time, what do you think I would add here? So remember in our here, we had these changes that we kind of represented on our line. What would I add to my diagram kind of in that circle that I drew there? Any ideas? Mhm. Exactly, yep. This change right here, because these are the changes that we want to add to our commit. So we will take the hi.txt, and we'll say that happened right here. So this would be plus hi.txt. Right, so that change has happened in our project between when we created our repository and when we created our new commit. Any questions? All right. Now what happens is when we create a commit, right, we have saved our draft. So our draft becomes a commit. That means that we erase everything that's in here, right? And the reason is because once we have saved this hi.txt and we have committed it, it's not going to be part of the next commit because it's already been saved. So we can remove that from our draft. Now let's look over here at our next line, hello world, and then the double arrows into hi.txt. So if you remember, the double arrows appends to a file, and the single one overwrites. Yes, right? Yeah, okay. I also get confused sometimes as well. So we added sup here, and now we are trying to concatenate world to our file. So what would my file look like now? What would the text look like after this is run? Any idea? Yeah? Exactly, yep. So we add sup world here. So, okay. Yep, we have sup world that we've added, and that takes care of this line. Now we have the second line right here, echo cookie into food.txt. So what might happen after I run this line? Yep, looks like this is still recording here. Yeah, all right, everything is recording. Sorry about that. So yes, you're correct. We create a new file right here called food.txt. Sorry, what is happening again? All right, here we have food.txt, and we have this cookie in there. Okay, great. So that is now done. All right, so we now have this line, git add food.txt. So what would this do? If we looked at our previous step and we had this git add hi.txt, what happens now? Or what would I add to my drawing based off of just this line, git add food.txt? Yes?
Put it in the draft commit?
Exactly, yep, we put it in the draft commit. So we examine what change has been made since our previous commit. Well, we added a new file called food.txt. And so I add food.txt, just like so. Now, I have my final line, which is to add a new commit. So we have git commit m, we have a message that says second, and we're going to add it to our diagram. So I will add a new commit. Sorry. All right, there we go. Add a new commit, and I can give this any ID, like I'll just give it 111. And what is the change that has occurred since then? What would I add in this circle? Oh, sorry, where? Yes. Yes, food.txt is added. Now, this should raise a question if any of you have been paying attention. You see that we have added hi.txt and we have added food.txt, but you'll notice that in the line above here with this echo, right, we modified this hi.txt file, right? This hi.txt added this world text in here. Yet we didn't specify that we actually modified that file in our commit history. And this is a key thing to keep in mind, right? Even though we modified a file that was previously added to stage, so we modified hi.txt, and remember we had plus hi.txt here, right? Before, when we made that commit, which we did here, we clear our stage. So we no longer, that hi.txt is no longer in there, right? It's completely blank. And so we only added food.txt, and so our commit history here is only going to include the changes that added sup and that added cookie but not that added world, right? Because we didn't add it to our draft commit. So this is where things get a little bit weird, because we have in our actual file, our file is showing sup world, and food.txt is showing cookie. But in our commit history, that change is not actually there. The reason is because we didn't add it to our commit, right? So we only added these two changes. And so that is why this is a common problem in as you're working, even in your classes, as you're taking them. You may only add certain files. You may forget to add all of your changes. So then, if you're looking at your Git history later, then if I were to, for example, jump back or give this to somebody else, and they were exploring the repository, they wouldn't have this world text added to their file, because this was not saved in our timeline that we're making, right, of the history of our code. So the key thing is if we want to avoid these problems for the sake of our beginning work, we're going to assume that for the most part we want to add every file to our repository. And so a very easy way to do that is just using git add dot. Right? So you'll see this a lot, and as you're working with your, you'll probably start getting, this will become muscle memory, because this dot is going to add all of the files, all of the changes. Remember what dot is, right? This is this is referring to the current working directory. So it's going to add all of the changes, right, in our directory. So that includes both editing hi.txt and creating food.txt. Right? So when you're working on projects, it's very useful to use this command, git add dot, instead of adding every single file manually. Because if you add every file manually, there's a very high chance that you may accidentally forget to add a file, and that may mess up your commit history. Are there any questions about this? Yes? Good question. Yeah, I probably should have included that. Sorry? Yes, okay, yeah. The question, for those who didn't hear it, was we added these commit messages, right? This commit one and commit second. Where are they in our diagram? And technically, these are actually part of the commit. So you could include text like this that says commit one. So commit one, and you could have second. These are, in the purposes of our diagram, these are technically part of the commit. So if you are working with Git, you will see these messages. In our diagram, since we are only including the IDs, at least in the previous version, we didn't really include these. We can kind of just keep them off to the side. But yes, they are there. So that's a very good point. They are part of every commit. And you can choose how you would like to diagram this. You can either put it above. You could kind of have like an arrow saying this is the message. You could even include it inside the circle if you want to include both the ID and the message. Good question. All right. Any other questions about this? All right.
I got a question I'll ask them.
Oh yeah.
Okay, so can anybody think that, we see that this can cause some issues with our stage if we forget to add files. Why do you guys think that is? So is there, what benefit comes to mind for having a stage versus just commit directly adding everything that you made? And what disadvantages are there? So let me phrase that again. Git could have been made where it's just when you do git commit -m, whatever, it'll automatically take all your changed files, all your added files, and put all those in the commit. But as we see, it's a two-stage process. We first have to add the specific files we want and then commit. What do you think the advantages of this process are over just directly committing any changes? Are there any? And what are the disadvantages too?
You
You could just shout out just whatever comes to mind.
Yeah.
You quickly check all your files before you upload them. So basically, in case making sure there's something left over, or you prevent future merge conflicts, I think.
Yeah, that's a good, to summarize that, it's just you can sort of see quickly what's going to be in your commit before you make the commit. That's a good point. That's the point. It sort of acts as like a temporary intermediary, so you can see, okay, what exactly is going to change. And there might be a situation where you're working, maybe you're testing out little things, and you change 5 files, but you're like, oh, I only actually want to save this one thing. It actually happens a lot. And so by allowing you to only add that one file, it's much easier because otherwise you get all your changes in one go. So yeah, that is the benefit. That's why the system is like this.
Yes, and also I will also point out, because this is jumping maybe slightly ahead, but also in some projects, for example, a common one is actually these days with ChatGPT and OpenAI, right? So you can actually, in a Python project, import ChatGPT and you can use it inside of your Python code. However, in order to do that, you have to supply what's called an API key, which is basically a password that is given, that you pay for, right? So you pay for this access, they give you a password, and you have to put that password into your code so that that you can use your project, and you can actually, your code will run. And the problem is that because that is a paid, password basically to run ChatGPT, if you were to add this to your commit history by just adding all your files in, you will find that is now public. So if you're sharing your code with anybody, even if you delete it later, it still exists. It still exists in your history. So if somebody really wanted to look through and find and steal your password and start charging you, they can, right? And so that's another common case here, is being able to pick and choose what files that you add. So for example, you may create another file that just has that password in it, and don't add that to any commit. So you keep that out of your history entirely. When you do git add, you ignore that file, and then you add your regular code. So your password is no longer being uploaded to Git, and maybe that only stays on your computer. And later on, I think we may talk a little bit about this and how we may get that. You may actually have an example that you'll see where we use this. But that's just something to keep in mind as well. So in addition to checking your work and making sure that you're only sending up the code you want, another key thing is if you have sensitive passwords or information, you don't necessarily want that in your Git history. That's a great question to bring up. Yep. All right. Any questions with this example? All right. So. Right. Okay, so let's go through. So we finished this example, and I'm going to now introduce the next big concept for Git. This is probably one of the most used items. This is called a branch. Okay, so a Git branch. Now, a branch is simply just a label that is attached to a specific commit. Right? So what happens here is, by default, Git creates a branch called main, which is just a label that has the text main on it, and it points it to a commit. Now, another thing that we kind of lied a little bit to you before, where in this example we showed how head is just pointing to a commit. Actually, the way that, and we wanted to show this first so that you kind of have an idea of what head is actually talking about and how that's pointing to your most recent commit. But in reality, head actually attaches to a branch. It always attaches to a branch. So I am currently on what is known as the main branch, where main is a label. It's just a label. A lot of people get confused because branches, you think of a tree and you think of that, if you have all these different I don't want to use the term in the definition, like all these different branches, but different offshoots, right, of your history. And you think that entire offshoot is a branch. That's not necessarily the case. A branch is just a label. So, that's the key thing to remember. When we talk about a branch, you can kind of think of this like a sticky note that you're putting on a commit, right? This is a label for that commit. And that's all there is actually to branches. So branches, they stick to a commit. And you also have head, where head is attached to branches specifically, not to a commit. So right now, we're looking at our code is on what we know as the main branch. So there's a branch which is pointing to this commit, and head is pointing to this label. So it says that I'm currently looking at the code that is marked with this main branch label here. Are there any questions with what a branch is? All right. So I know that this is this may seem a bit weird, but what we want to emphasize, a branch is just a label that is attached to a commit. There's nothing more There's nothing more fancy about the definition here. That's really all it is, okay? Now, the key thing is, another thing with branches is that if I'm on a certain branch, so let's say head is pointing at my main branch, which is my main label to attach to this particular commit. If I create a commit right now, remember just like in the past, we just added to our timeline. So we would go here, we would add a little flag post that's a new commit. But what happens is when we do this, if head is pointing to a branch, the branches we're working off of, this label moves to the new commit that we make. So for example, if I create a commit with the ID of all 8s, right? So you'll see that before I was like this, and I was working, maybe I was making some changes here, like I'm adding, deleting files, and I make a new commit. That new commit, once it's made, the branch main and this head label move with my progress. And it may seem a bit weird, but think about this, right? Like if you're making a change and then you save it, right? Your current project is going to be, the changes that you made are going to be what you actually see in your folders, right? So just like before in that example with our that we drew out, when we added that hi.txt file and we committed it, right? That change doesn't disappear. It's still in our folder, right? That change is what we've made. And so what we're looking at then, remember head is the label of what we're looking at in our actual project, that should ideally add to the new, or move to the new commit. Because if I make a new commit, that means that I've made a checkpoint, I'm now at that checkpoint, and so head should move. If you want to think about this in Mario terms again, if you have 2 different checkpoints in Mario, just by hitting the second checkpoint, you don't teleport back to the first one, right? You stay at the new checkpoint that you hit. So it's kind of the same idea here. So head moves over, and the branch that you're on also moves over. So head, because head is pointing to a branch, and head is now moving, so everything moves over to our new commit. Are there any questions with this idea of how when we create a new commit, head moves along with it? All right. Perfect. So we talked, this was a bit of a review from last time as well, this piece, where we use this git checkout command. Does anyone want to remind everyone what git checkout does? So in this case, I have git checkout, I have this ID. What would actually happen if I ran this line in the terminal? Yeah? Makes a new branch. Close. We're getting to that. Any other suggestions? Yeah?
Doesn't it move the head back to that flag?
Exactly. It moves head over to this commit. So what that means is you can kind of think, we have this word checkout, right? Like if you're looking at a store and you're like, hey, check out that new store, check out that new cafe, you go over there, right? And you check it out. It's the same idea here. So when we check out a commit, head, which is, remember, what is the label of what we're looking at, that's going to move back in time. So you can see if I run this, my head now moves back to, in this case, Chris Jordan moves back to commit 3D51. Because now we're checking it out, we're taking a look at it here. Now, you may think that, okay, well, you just said a few minutes ago that head is supposed to be pointing at a branch and not a commit. Yet now we're looking back at a commit. And it is still true that head should be pointing to a branch. This does work, but you're going to get the really scary error, detached head state. Okay, so now detached head, we can kind of talk about what this means. Detached head means that head is now detached from a branch. It's not pointing at a branch anymore, and it's looking at a random commit where a label is not attached to it. So you can see here, we've checked out to this random commit, and head is no longer pointing at any branch. So how do you think we may want to fix this particular problem? If head is supposed to be on a branch and we moved our head back, how can we get it such that head is now pointing at a branch again? Yeah?
Did you create a new branch?
Exactly, right? You can create a branch. So branch main is automatically created when you start a project, but you can add your own branches. And if we're told that head is supposed to point at a branch, well, we can just make a new branch where we are, and that should solve this problem. So to do that, we checked out already. We have this very nice command, and this will be updated as well in that document that I shared over the weekend, where we have these where I wrote all the commands. We have this get branch command, and get branch is actually going to create a new branch where we are. So you can see here, I'm at this commit. I'm creating a branch called whip. Now there's a note here because this is something you'll see a lot. WIP stands for work in progress. So as you're working on something, maybe you're trying to experiment with something in your code, a common acronym people use is WIP, work in progress. So if you ever see that, that might be what it stands for. And so you can see when I run that, what's going to happen is I'm going to have a new label, a new branch, attached to this commit with the name WIP. And now head is going to point to that branch because we're still on the same commit, right? And so that solves our problem in terms of now head is pointing at a branch. Any questions on creating branches, the detach head state, etc.? All right. So now you may be wondering, how do I switch between branches? So, I'm at WIP, and just like how I did get checkout to find a specific commit, how can I change which branch I'm looking at? So if I'm currently at this WIP, I'm at the commit where the WIP branch is attached to it. What if I want to jump over to main, right, and move head to our main branch? Well, we can use the git switch command to switch our branches. So if I'm currently at my WIP branch, as you can see, because head is attached to WIP, and I run git switch main, I'm going to be switching to the main branch. So it's going to look at all my branches, it's going to find the one with the same name, and it's going to take my head and it's going to move it over there. All right? So you'll see that when I run this command, Chris Jordan will automatically, he goes from WIP to main. We've switched branches. And so our project, the code that's actually in our folders is going to change to represent, to represent the progress that our timeline shows. So what I mean by that is, if I'm here, you'll see that I have these three changes that are currently showing in my project, where I added my main file, I added script, and then I modified main. But I made these two changes where I delete main and I modified script. I did that in the future, right? So this is one checkpoint, which was placed before that stuff happened. And then when I switch, then it's going to change my project so that it reflects these changes, right? It's like if you're on a timeline. I don't know if Google Earth still has, but there's usually like a timeline at the bottom where you can go to previous years, right? So if you're at a building and you scroll in the past, that building will not be there. It's kind of the same thing here, right? So if you scroll back in time, your code is going to look how it did in the past. When you scroll to the future, it's going to show, or to present, it's going to show what your code looks like at the present time. So does everyone understand that, the connection to kind of how this is similar to a timeline and scrolling through that? Yes?
So it's like each tag or each branch, like main, can that only be like on one commit?
Yes,
Okay.
yes. So yeah, branch can only be on one commit.
Okay.
Yes. Any other questions? All right. We're at 45, right? Okay, good. Want to make sure I'm not going too slowly. All right. And I also show here just switching back and forth, right? So switch main, switch whip. All right. Now remember this. This is kind of, we modified this a little bit. This is the last slide last time, which is what happens if I start making changes from a previous commit. Right? The only difference here is now I actually have actual branch labels. So what am I saying here? Well, I am saying that if I'm at my, I was at main, I switched to whip. But then what if I change my code here and I make a new commit? What is going to happen? Right? Because here I've already made these changes. I've modified script. I deleted main.py. That is happening between these two commits. But what if I say instead, okay, instead of this happening, I'm going to do something else. Let's say I add a new file. Right? So in the end, what my timeline looks like is there's now a branch off of it. Right? So it kind of looks like that. I'm going into uncharted territory, right, beyond. I'm breaking up my timeline here. Now, I will point out that, actually, I'll just go to the next, I'll go to the next slide. So this is another representation, which is if you saw I was starting to draw it, but then I went back to flags. Instead of drawing flags, a lot of times in other classes, you'll just use circles to represent each of your commits. The flag post was kind of to reinforce that checkpoint type of idea. But now that I think you all are a little bit more familiar with that, we can move to this more standard representation where you have circles. So you can see these are different commits. And these commits, right, it's the same thing here where our changes, we have our branches and main. So now what's happening is, let's say I'm making changes. So I'm at this particular commit. I'm at this checkpoint. And then I start going in a different direction. And I start making different changes. Well, what's going to happen? Well, let's create a commit. And you'll notice now that I have a commit that is no longer on my main timeline. I have my main timeline down here, and I have my main branch. And then here, I made changes from this point. So this is this is the point where I started, and then I make different changes than the one I made over here. Well, if you remember that, just like in the beginning, all the way back, if I go right here, remember how when we create a new commit, right, it moves our branch label, and it moves head along with it, right? So I've created a new commit, main and head has moved over. Well, when I'm here, right, just like here, remember head and whip were over here, but then if I make a new commit, the head and the branch it's attached to is going to move with me to my new commit. So now I have this new commit right here for BC3, all right? And whip has moved and head has moved. All right, so now I want to show, actually, before I do that, any questions on what's happened on this diagram here and what has happened? I don't know if anyone watched or has kept up with any of the Marvel movies, but there's in that there's a multiverse and the timelines were branching and everything. You can kind of think of that here, where you have these alternate realities, and that's kind of what's happening, right? Our code now has alternate versions of itself, depending on what kind of branch you go off of. And that's the key thing. You notice I'm using the word branch because in a timeline, right, things branch off. That's why the terminology is a bit confusing, because we say branches, all right, are these labels that are attached to commits, but also just like a tree branches, right, we're branching off. When we say branch, like the whip branch or the main branch, we're talking about the label. We're not talking about the entire, like this offshoot only. So when we say whip, we're not just talking about this line, and when we say main, we're not just talking about this. We're just talking about the commit that it's attached to. Okay. So I want to move into an example here. I think I should have time for this. So let's go to my terminal. All right, so this is something that you do not have to necessarily follow along with because you won't have. But if you would like to still watch along, I think this will help to connect things. So we'll actually see this happening in our code. So what I'm going to do is I'm going to go into my setup folder for today, which is lesson 5 in the Comp290 folder. And I'm just going to type in ls so that you can kind of see what I have in this folder. So I have a file called feature.a.py. So you can think of this like a new feature to my app. I have main.py and I have script.py. And I can open this in VS Code just to show you. So what you can do is you can type in like pwd and this will give me my entire path like this. And I can go into VS Code here, so Visual Studio, ignore this. Let me close that, close folder. Okay, so when you open VS Code, it'll look like this. And there's this open button here. Is that what you're? Okay. If you press open, now you can also just navigate it too manually. So you saw that mine was users, my name, Comp290, lesson 5 right here, and I can just press open. So you can see what my code actually looks like. So I have, yes, I trust myself. All right, so this is what this looks like here. We have 3 files. I can open each, and you can see this is very bare bones. We have print feature A. We have a comment here. We have main.py, which just says hello world. And we have script.py that says running script. Now, a cool thing in VS Code is you'll actually notice down here, it should tell you what branch you're currently on. So you can see there's like this little Git icon, and then it says main. So it's telling us that we're currently on our main branch. And you can actually see we have create a new branch. We also have that checkout detached. Remember, this is our git checkout, where we can check out another commit and it detaches our head. But let's view this in VS Code. So, or sorry, not in VS Code, in our terminal. So you remember, I think I have it here somewhere. I have way too many windows. Let's see, slideshow. Yes, remember this from last time. This is our, I hope I showed this last time. I did, right? Yeah, this is a random meme, but it's somewhat helpful for remembering the git log command, which allows us to see our git history. And we can add these different flags, so all, decorate, one line in graph, just to make it look prettier and be easier to read. So I can type that in here. So I'll type, where's my mouse? Okay, git log, and then I'll write this out. So it's all decorate one line graph, like so. These are all the different flags. And when I press enter, you'll now see a representation of what my git commit history looks like. So you can see that I have these 4 commits, and it's going from oldest at the bottom to newest at the top. You can see that I have a branch called main, which is pointing to this C25E76 or C2 command or commit, and head is pointing to it. So because head is pointing to this branch, it means that I'm currently looking at it. That's what my files are in the state of this commit. Now you'll also notice that I have another branch down here, which says whip. So I have 2 branches, and this is, I made this for this lecture, so you can see this is kind of a similar thing to what we had before. We have a main timeline here, and then we have whip. All right. So now, what if I try and do the same thing where I go to whip and I branch off and I start editing my files? So what I can do is first, I need to move my head from main to whip. So does anyone know what the command might be to switch my branch from main to whip? Yes, exactly, switch. So we say git switch, that is for switching our branch, and then we type in whip. And it says switched to branch whip. So if I were to run this git log again, you'll now see that head is pointing at the whip branch. And you'll notice that when I jump over to VS Code, notice how feature a.py is now gone, right? Because I created that. If you look at my commit history, you can see I created feature a here. So this is further in the timeline than where I am. So that file is now gone, right? It's not there anymore. We can get it back by switching to main. So if I'll just show for example, git switch main, you'll see that now feature a is there again. So this is the cool thing about Git and how we can traverse the history of our project. But let's switch back. Git switch whip. All right, I'm going to clear now just so that we are a little bit easier to see. And let's modify one of our files. So let's say that I create a new file, actually. I'll do that right here. So I'll say new file, feature B. I was going to do this using the command line, but I think it's easier to just see it this way. That way I don't overload too many things on you. Let's just say print, whoa. All right, print feature B, yay. All right, so we have now added this feature B file to our folder here. And now in Git, what would we have to do to add this to our stage and commit? I pretty much just said already in my description, but I'll write it. It says git add, right? So we can add our file manually, or we can just type in git add dot, right? Now again, I want to emphasize this git status we showed last time. You can see here that it tells us what is not in our stage right now. So we modified feature b.py, but it's not part of that draft commit. Now we can add it by doing git add dot. And if I type git status, you'll see now it is there. So now it's green. It says that see changes to be committed. And we have feature b.py there. So let's make a commit. So I'm going to have git commit. Let's supply a message for add feature b. And you can see it says add feature b. One file changed, one insertion, we added feature b. So now, what would it look like if I did that to git log? So git log, right? You'll now see that there's kind of this weird, it looks a little bit weird, but you can kind of follow it, that we have, this was where we started. This is where whip used to be, right? Create script.py. And then we added a new commit, which was add feature B. And so you can see there's these two different lines, right? We've branched off. So and our previous history just went to create feature A and modify feature A. But since we were here, we instead of following this, we created a new commit here for add feature B. So how does this look, or how does this make sense as to why we have this representation? Perfect. All right. So now the question naturally follows. Let me see if I can go back here. Right? This is kind of my representation. This should be very similar to what was on the other thing, just with different IDs. So I'm now, let's say I'm working right on something. I'm adding this feature B. But now I want feature B, I want the changes that I made to be added to my main history. Right? So I want my main branch to not only have the changes that I made here, which in our case was creating feature A, but I also want it to include feature B. So my final version that I want, right, where main, and I'll go back here, right? On this side I had feature A, and I want both feature A and feature B to be together. Right, that's the ultimate thing that I want in the end. How can I do that? Well, there is a very cool feature in Git, and why Git is so useful, called the Git merge. And what Git merge does is it combines two different Git histories together. So we can call like our main right here, this was different, a different history from whip. And we're combining it together such that the changes on the whip branch and the changes in main are combined together, and they're both in the same commit, and now both of the changes are there. Right, so we have this thing called a merge commit, which has two parents. So typically every commit points to just one other item, but a merge commit points to two, because we are taking two different histories and combining them together, right? So we have 5b23 and the 7342. We want both of these, right, to contribute to my next commit here. So I think, and Noah may actually also be able to talk about this a bit, but why is this so useful? Well, you can imagine, just like as we have talked about in the past, you may have one person working on one feature. Like maybe you say, okay, I don't know, Noah, add a button right on the homepage, and then maybe Chris says, Ajay, add a header onto another page, and we're both working at the same time on our project, right? We are working maybe in two different branches. So maybe down here is my work that I'm doing, and then up here is Noah's work that he's doing. But ultimately, we want both things that we're working on to be added to our final website, right? So we want to be able to take the changes we made independently and combine them together so both of our features are together. How's that sound?
I think that's pretty good.
Okay,
Yeah.
Great. Does anyone have any questions as to why we might want to do this? All right. This is, of course, a more high level. We're going to go into it now. So this is I did not create the grade scope. Do you think you can create the grade scope assignment for the lecture? Okay. So there's an attendance check. We'll spend a few minutes on this, maybe 3 or 4. Talk with each other. We have these changes. So again, remember, sorry, it's still small. Plus is adding, star is modifying, and minus, which is not here, is deleting. And I have these two different histories. You can see one where I modified main and add readme, and then here where I add this feature. What changes would you expect for this final commit here to show? So feel free to talk with each other and think about what changes should be, like there's a question mark, what should I replace this with? Just go off of not necessarily what it does, but just off of intuition, right? Like what do I want? If in the example here where we were adding two different features to a website and combining it, what do you think should go here? So you can feel free to submit this to the attendance check and also talk in your groups. Noah should be adding it now. We'll give a few minutes on this. If you submitted for this one, that's fine. This text is wrong. This should have been 1C4B. But it's okay. If you submitted the other one, it's fine. Don't worry about it. We'll be talking about it. That is my fault. I added one extra commit in this diagram last minute and forgot to change the text. So, I mean, the question mark was on that one, but it should be fine.
It's grading on attempts.
Yeah, exactly. Yeah, we're grading on the submission, not like that you submitted, not the correctness, of course. All right, so does anyone have, if anyone did the correct one, the 1C4B, does anyone have any idea of what should be part of it? Yeah.
Just plus feature.py.
Yes, plus feature.py, plus feature.py is one thing. In fact, is that it? Let me see. Yes, exactly. So you'll see here that technically, the way I've written it here, I'm just showing that both of these changes happen, but really this would be just one create, and you'd create the edited, like you'd only have the one change, which is the created version after all of these two things have been done. So it would just like take this file, like let's say feature was just print A, and then we modified it to say print B. The final one would just have add feature.py, and it would say print B. It'll just combine both of these changes together. But yeah, basically both of the things that would happen up here, because why wouldn't main.py and readme be in this particular change? Why do you think? Does anyone? Yeah.
It's already in that branch.
Exactly. It's already here, right? So if I'm creating a version, and actually, this is a bit of a caveat because we're on the main branch. We're merging from whip into main. So our whip here, has its changes. Main already has these changes in the past, so we add the two changes that are not there to our final commit. Now, technically, because I did show this last week to 423, and Chris Jordan did provide a very useful note, which is actually under the hood in the way that this works. What changes are actually stored in this commit may not necessarily be all of the changes that are here. It's going to mainly just be pointing to the two, and only very few lines on kind of the differences between these two and how they're actually added. You don't have to worry about what that actually does in under the hood. The main thing is just realizing that when we have this commit, it should include all the changes from up here and all the changes from down there. So if you said anything like that in the answer, that's all correct. Okay. Now, how would I complete this merge? And perhaps I should have shown this. Maybe it would have been useful to show this first, so that we're talking about what merges into what. But if I want my merge commit to be on the main branch, so you see that when I did it, my main moved from here to here, and head moved from here to here. We didn't go from whip down, right? So if we want that to happen, we want to first, before we merge, we want to switch to the branch that we expect to be on when the merge is done, right? So in this case, when we create our merge, like our merge version here, we have this main branch, and we want this new merge commit to be on our main branch. We would first switch to main. So first you would switch down here to main, and then once you're on this branch, then we run the git merge command. And you run git merge, and sorry, I'm going to edit this real quick. This should say merge whip. I changed the name. So you would use merge and then the branch that you are trying to take the changes of and add to where we are, right? So we're merging the whip branch. So the changes made here, we want to merge that into main. So in the end, we would be on our main branch. So when I run merge whip, right, you can see that I have created a commit, and it's still on the main branch because that's where we switched to. Sorry, the text here is also wrong. I thought I changed this. Main and whip. I want this to be consistent. There we go. So we switched to the main branch first, and then we merged whip into it. So we take the changes, we add it to this merge commit, and now we put it off of main. And git commit is one other command because what merge will do is it'll open a text editor for you to add like a git commit message. And if that hasn't, like if you don't save it properly, then you may have to run git commit again. It would tell you if you need to do that though. I'll show that actually here. So in this example here, let's say I want to do the same thing where I want to take whip and I want to merge it into main, right? So what is the first step that we need to do again? What is the first command? If we want our final merge to be on our main branch, what would I have to do first? Exactly, switch to it. So we'll have git switch main. And now, if I log, you'll see that head is now pointing to main. And then I want to merge whip into main, so git merge whip. And you'll see this is where we now have this text editor. And actually, this is, see, it says, please enter a commit message to explain why this is necessary. And so I can add here, like, actually, do you remember how to? I have not used this in a second, so.
Hit I to get
Thank you.
Yeah.
Yes, so this is something called Vim. We're not going to be talking about this until a few weeks from now. It is basically, you know how we have VS Code to edit code? We can actually edit code in the terminal, like in the command line. But it's too complicated for the beginning, so we're not going to talk about that for now. But yeah, I can add in here like, I don't know. Lines will be ignored. Okay, 1 second. It's merge commit. All right, I'll just say that. And then I think I have to do like WQ, is that right? Again, you don't need to know that. This is for saving the text. What'll happen if you don't know any of this, you can just close it. Actually, I'll just show you because it's easier. So it says, right, if an empty message, like, sorry, it's gonna make me do it. All right, so if for whatever reason you forget, which is totally fair, the WQ thing, you can just quit out and it'll basically give you a warning saying, hey, you created the merge commit, but you haven't committed it yet because you didn't supply a commit message. Then you can just type in git commit @ -m and carry on like normal. So you don't have to worry about the specifics of Vim and how to do that until later. All right. Now, though, you'll see it says merge made by, you can ignore the strategy piece. You see, this is the one change. We added feature B, right? Just like how we said, feature B was the one change. We added it here. And so if I run git log, you can now see that I had a branch off here for whip, and then we add it together, and both of our changes are combined. All right. Now, one last thing I'm going to include here, because we're running short on time, is, and we'll skip this example, is what happens in the case that we make two changes. So we make a change on this branch here, and we make a change here that are directly conflicting with each other. What I mean by that is you'll notice down here, we modify main.py, right? So we made a change to main.py. But up here, we deleted main.py. So when we're trying to combine both of these changes together, Git is going to be confused because it's going to say, well, did you want to modify main.py or did you want to delete main.py? What in the world is happening? What do you want to do? And that creates what I think someone over there mentioned earlier called a merge conflict, which basically means that Git cannot automatically, just like how it automatically created a merge commit for us, it can't do it automatically because there are two changes that are conflicting with each other. And as a programmer, we need to decide which one we want to keep. Do we want to keep the deleting the file, or do we want to keep the modifying file? Like, which change do we want to actually keep? And so the assignment, one of the assignments that'll come out soon is this. So what you'll have is we'll have a sample Git repo for you, and there'll be instructions. So you don't worry, it won't be too unguided. You'll try and merge two branches in that'll conflict with each other, and it'll be your task to fix the conflict and finish the merge. So that is all for today. We'll get to this next week, and we'll be sending out information about this. Thank you all. If you have any questions, feel free to come up and we can help answer them. See you all next week. Have a great long wellness weekend.